Hello everybody, welcome. Today I'd like to just review a few of the problems that may help you prepare for the exam, specifically some of the problems that may have been a little challenging on the homework. That is, especially problems where you had something in the denominator for some of the terms, other terms had nothing in the denominator, and your goal was to solve for x here, right? So, looking at this problem, right, our goal is to isolate x, right? We want some expression that says x equals something, right? That's our goal. And to get there, what we need to do is take the x here, and the x here, and get all of those on one side of the equal sign. But we've got a bit of an issue, and that is these two denominators, right? This entire setup here actually does not have common denominators. So we can't really juggle the terms around effectively unless we effectively remove these denominators, right? And the way we do that is through our typical process called our lowest common denominator process, right? So what we want to do is find a denominator that will basically remove all of these lower denominators such that all we have is stuff in the numerator, right? No fractions here. So, to do this, I see I have a 4, I have a 2, and I say, oh, well, right off the top of my head, I know 2 can go into 4, and 4 can go into 4. So, for this problem, our lowest common denominator is going to be 4. Now, what do I do with this information? Well, the next step would be to take this original problem and multiply each term by the lowest common denominator. So, I'll go ahead and get started, right, with this first term. I'll take 4, and I'll multiply that here, right, 3x minus 2. Remember, we're multiplying the entire term, so here I've gone ahead and added some parentheses so you can see that a little better. This whole thing was over 4. We also have our plus x, but we have to remember we're multiplying everything by 4. So we have 4 times x, right? We'll have our equal sign here. Again, multiply by 4. Not forgetting to multiply our entire term here by 4, right? 4 minus 2x, and this whole thing was over 2, and here we have our 1, which of course we're also multiplying by 4, right? We can see here for each of our terms, right, for this term, this term, this term, and this term, we have multiplied each and every one of those by 4, by 4, by 4, and by 4, right? We've done the same thing to every term in this equation. What's next? Well, let's just start by factoring, right? And the first one's pretty easy. You see that this 4 factors with this 4, leaving us with our simple 3x minus 2, right? For this next portion here, there's nothing in the denominator, so we'll just go ahead and write 4x, right? Because 4 times x, 4x. And now to tackle the right side of our equation here, we can see that these should also factor, but not completely, right? If I take a 2 out of this 4, that is, I can represent this 4 as 2 times 2, I'm factoring one of those 2's, but I still have a 2 left. And just so we can see this whole process, I'll go ahead and write it like this. So we can see, right, we haven't distributed that 2 in yet. And then right here at the end, we have our 4 times our 1, which, wouldn't you know it, gives us a 4, right? So now we can see that compared to where we started here, right, some of these messy numbers in the denominator, we have a much simpler expression, and we can actually start combining terms, right? So over here on this side, I'll go ahead and combine my 3x and my 4x for a grand total of 7x. Of course, we can't forget our minus 2. And we'll set this equal to, right? And this is the part that's tricky. We have to remember to distribute this 2 into both of these terms, right? Coming all the way back up here, we have multiplied each of these entire terms by 4, correct? Right? So what we did here, 4 times this term, 4 times this term, 4 times this term, and 4 times this term. And we have to remember, right? This whole thing here is multiplied by 4. It's not just the first number of this term or just the second number. It's the whole thing, which is why I went ahead and added those parentheses there. Just to remind myself, hey, this 4, which I suppose is now a 2, has to go to each of these individual terms inside of here, right? So let's go ahead and do what I've drawn out here, right? That is 2 times 4, which gives us a 8, and a 2 times negative 2x, which gives us a negative 4x. And of course, we can't forget about our minus 4, right? So here we have our equation that's now looking much, much better than our previous, all these fractions and denominators stuff here. And from here, we can go ahead and kind of start, or continue, I suppose, consolidating our terms, right? So again, over here, we'll just have our 7x minus 2. And over here, I'll put this 8 and minus 4 together to just give me 4 minus 4x, right? And then I'll say, okay, maybe I want my x over here on this side. So I'll add 4x. I'll do the same thing over here, adding 4x. Of course, negative 4x plus 4x, right? This whole thing here goes to 0. And 7 plus 4 gives us 11x minus 2 equal to, and we still have this 4 over here, right? And then I'll say, okay, well, I want to move this 2 over to this other side. We have minus 2, so let's add 2 to both sides, right? 2 minus 2, that's 0. So the only thing we're left with here is 11x. Over here, we have 6, which brings us to our final answer over here, right? Here we want to divide both sides by 11, right? And this will give us that x is equal to 6 over 11. Right? The key thing to remember here is that we need to find the lowest common denominator that allows us to get rid of all of these things in the denominator. And when we do, we have to remember that sometimes it'll factor completely, right? When we're just left with this expression here. But other times, for example here, the 4 did not fully factor. We had a 2 that remained out there. And we had to take that 2 and distribute it into both of these terms, right? Because this was one entire term up here. So we took that term, moved it down here. We managed to get rid of our denominator, but then we had to remember to take our 2 down to both of the things inside of this expression here, right? Thank you very much for watching. I will see you next time.